This is 10-6. We're going to take a look at summation notation. So we're going to find the sum of an expression or expressions in summation notation. Now, where does this summation notation come from? We have been dealing with series where, let me give you an example. We know that this right here, the 2, 4, 6, 8, that is an arithmetic sequence. And the idea with this sequence, the reason why it's arithmetic is because I'm adding 2 to every single term. We established a formula. I can find the values in the formula. Awesome. But the question now comes to, well, what happens if I want to say if this is the first term and this is the second term and this is the third and this is the fourth, etc. Well, what happens if I say I want to add up all of my terms? What would then that equal? Or what if I wanted to find the 10th term, adding them all up from the 1st to the 10th, or from the 1st to the 30th, or the 20th to the 50th, right? How can I add those all up? What does that look like? Well, that's where summation notation comes in. This symbol right here, that Greek letter, means summation. It is the capital letter of sigma, and it tells us, sigma, sum, to add up your terms. This is the starting value. This is the variable that we're defining. That m is the starting value. And then this p right here, that is going to be the final value, where basically it tells you where to stop. So the first term is here, or the starting term is here, and then the last term that you're going to be adding is going to be up there. So let's look at this first one. So this is saying, because it uses this notation, that sum, it means I'm going to be adding all the terms from the first term to the fourth term. So this is going to be 13 over 100 to the first power plus 13 over 100 squared plus 13 over 100 cubed plus 13 over 100 to the fourth power. So again, just to re-explain that, because it's using this sigma notation right here, this sigma notation tells me I'm going to sum all of the terms from my first term to the fourth term. And so there's my first term. I'm adding it to my second term, to my third term, and to my fourth term. And so what you're going to do is you're going to take those and you're going to add those together. And so by adding those all together, you're going to get 0.131313, and it's going to keep on going. Technically, I could just done 0.13 with that there, but it's 0.13131313131313, etc., etc. So this one here, this is saying add up all of my terms from my first term being 0 to my fourth term. Now, I don't know if we've gone over this or you've seen it in math before. This factorial notation, it means multiplying all the factors down to 1 from that starting number. So for example, if I said 5 factorial, that's the same as 5 times 4 times 3 times 2 times 1. So you start with the number 5 and you multiply by all of the factors counting down. So counting down 5, 4, 3, 2, 1, and you're going to multiply those all together. So the other little thing is 0 factorial equals 1. That's a definitional thing. So don't know. We didn't really talk about it too much in this class. Don't know if it's been talked about in other classes. So not too bad of a concept, but let's apply it to this. So it's a sum of all the terms from the 0 term to the fourth term. So this is going to be 0 factorial over 2 plus 1 factorial over 2 plus 2 factorial over 2 plus 3 factorial over 2 plus 4 factorial over 2. So this is going to be 1/2 plus, and then 1 factorial is just 1/2, plus, and then 2 factorial, that's 2 over 2, because 2 times 1 is 2, plus, and then 3 factorial, well, I can write those off to the side. So that's going to be 6, so that'll be 6 over 2, plus, and then 4 factorial. So that's 6 times 4, which is going to be 24. So this is going to be 1 plus 1, because these together give me 1. That's going to be 1. That's going to be plus 3, and that's going to be plus 12. So 1, 2, 5, 17. I want you guys to give this one a shot. Ooh, and yes, your answers can be in terms of x. All right, so let's go over this one. So my first term is going to be -1 to the 1 plus 1 over 1 times x minus 1 to the first. Plus, my second term is going to be -1 to the 2 plus 1 over 2 times x minus 1 squared. My third term is going to be -1 to the 3 plus 1 over 3 times x minus 1 to the third. So this is where, and sometimes if this helps you out, do it. You can go ahead and write in what your terms are above it, and it helps you keep track a little bit. So then n equals 4. That's going to be -1 to the 4 plus 1 over 4 times x minus 1 to the fourth. And then plus -1 to the 5 plus 1 over 5 times x minus 1 to the fifth. Phew, that was a lot. So now we just got to simplify each one, and we can leave it at that. So this turns into squared. Well, -1 squared is +1. So I'm going to get 1 over 1 times x minus 1 to the first. Well, that's just going to be x minus 1. Plus, now for this next one, I get -1 to the third power. So that's going to be -1 over, and then it's 2, and that's going to be times x minus 1 squared. So that's going to be minus x minus 1 squared over 2. Now my next one, 3 plus 1 is 4. So -1 to the fourth is +1. So I'm going to get plus, and then it's a 3 on the bottom. And so that's going to be x minus 1 to the third. This next one, when I plugged in 4, 4 plus 1 is 5. -1 to the fifth power is negative. So I'm going to get -1 over 4. And then, well, times x minus 1 to the fourth. And my last one, when I plugged in 5, I get 6. -1 to the sixth power is positive. So that's going to be plus x minus 1 to the fifth over 5. And that's it. That is the summation of those. It's just in a variable, and it's okay that it's in a variable. So what did we learn today? We learned about summation notation and what it means. Just a quick recap. When you see this symbol here, that means you're going to be adding up your terms. We're always going to have your starting term, and then it's always going to end at some number up here. So this is saying add up all the terms starting with the first term, and you're going to end at the fifth term. This does conclude our lesson. If you have any other questions, please leave them in the comments.